Welcome to today's FDTD Satellite Applications webinar. Today, we're very happy to have Mike Seaman and Alex DeSmet from the Forecast Office in Salt Lake City talking about a review of the December 2021 Northern Utah snow squalls. Next slide, please. This is an ongoing seminar series, webinar series. I'll wait till you, there we go. We're always looking for presenters. I'm Scott Lindstrom, Dan Bykos at Sierra. I'm Scott Lindstrom at SIMS, Dan Bykos at Sierra, and I help coordinate this. So if you have a topic, a recent forecast-related topic that used satellite imagery that you'd like to talk about, please get in touch with us. We can help you develop imagery if you don't have it, or just sit back and watch what you do. Next slide, please. And we'll have about 20 minutes for the speaker. Send any questions you have via the chat. Don't press hold. Mute when you're not speaking. Take it away.
Okay, thank you, Dan and Scott and everyone for attending today. This is a picture from our December 27th, our second consecutive days snow squalls that rumbled through northern Utah. This was a picture from North Salt Lake looking northwest towards Antelope Island, which is the largest island in the Great Salt Lake. So just a little bit of background on that picture. So first of all, we thought we'd start off by defining what a snow squall is. So as you can see, it's an intense but limited duration period of moderate to heavy snow accompanied by strong gusty winds and possibly lightning. Now, not every high impact snow squall event is accompanied by strong gusty surface winds, but many of them do happen to be accompanied by strong and gusty winds. Taking it to the next step, we'll take a look at the QLCS snow squall conceptual model here. This tends to be the higher impact variety of snow squalls due to stronger forcing, higher snowfall rates that accompany these features. They're typically accompanied by the presence of an upper level trough and strong surface cold front, and form in the presence of strong frontogenetical forcing. So as you can see here in the conceptual model, you can see that frontogenetical circulation depicted there. Also typically accompanied by a strong pressure rise fall couplet. And most of the time, even though these are winter type scenarios, surface-based CAPE of 50 to 100 joules per kilogram tend to be present in advance of these features. And also some strong winds aloft, typically on the order of 30 to 40 knots at 1.5 kilometers as well. So as a warning forecaster working the desk during these events, and for the rest of the forecast team, it's important to utilize the total observation concept. What do we mean by that? Well, typically these features are shallow and can be difficult to detect by radar. And that's where the use of satellite data can come into play to help fill in the observational gaps, as well as surface observations of webcams and roadway DOT sensors as well. And also anecdotal reports from social media and traffic reports as well, such as Google Maps with the traffic layer turned on, as well as local DOT websites that contain up-to-date traffic information. Some things that can help is if you have high confidence in upcoming snow squall event, recommend requesting a mesosector to help fill in those radar gaps. The 1 minute temporal resolution of that product is very helpful. And also some of the products can help identify glaciation in these clouds as well to help detect strengthening convective features. There's typically two modes of snow squalls, both the linear and the cellular kind. Obviously the QLCS kind is going to be the linear variety. Those tend to be more organized and intense with heavier snowfall rates. And the cellular modes are typically less organized and less intense, but those can occasionally contain heavy snowfall as well. And there's been some correlation between significant events containing 30 dBz or higher radar reflectivity and also 30 knots or greater of radial velocities. So sort of the 30-30 rule, if you will. Here's an example from February 20th in eastern Idaho, where we had a high-end snow squall event, which actually produced surface gusts as high as 70 miles per hour and near zero visibility as this band progressed southward through eastern Idaho. So this particular event, you can see we had both of those 30-30 criteria met in this particular case, just as an example. So what might a snow squall look like as it passes over an RWIS or a webcam? Well, here's an example from Idaho looking at an impending snow squall approaching the camera. You can see some well identified structure there, shelf cloud out in advance of this feature. And here's what it looks like as it passes over the camera. You can see roads have become slick, snow covered. As the snow squall progressed eastward, it became stronger. So you can see it's difficult to even find the road here that goes to the center of the image. And you can also see the low visibility. Here is the same snow squall passing I-15, producing some very treacherous travel conditions. So this is sort of a ground truth indicator of the high impacts that are occurring as a result of the snow squall. And in this particular location, the snow squall was not identifiable on radar due to beam blockage. So utilizing this webcam image was very useful in this case in confirming the existence of the squall. So I'm going to pass it over to Mike now as he talks about our December 26th and 27th events.
Okay, thanks, Alex. I'm just going to do a meteorological overview of the two snow squall events we had. The first was on the early morning of December 26th, and after Christmas, it was a Sunday morning. And the second event will be the following day on December 27th during the evening. So back-to-back days where we had snow squalls. First off, just kind of setting up the large-scale pattern for December 6th or December 26th. Looking at mid-level water vapor imagery, we could see a pretty well-defined upper low over the Pacific Northwest with a long-wave trough in place across the Intermountain region. During the latter half of this loop, you can see a fairly well-defined shortwave vorticity maxima lifting out of northern Nevada across the northeastern Great Basin into northwestern Utah, and we can see quite a bit of ascent being forced ahead of that wave over northern Utah and eastern Idaho. Some of the parameters we like to look at when assessing snow squall potential is low-level frontogenesis, as well as the snow squall parameter, which is kind of a newer parameter that we've been kind of assessing here. So I'm going to step through these real quick, starting at 11Z. As that trough is lifting across northeastern Nevada, on the left of the screen, we see some frontogenesis along that boundary. But as we step forward through 13 and 15Z, we see a considerable increase in 850 to 700 millibar frontogenesis by 15Z. Also coincident with that line, as I step back and forth across northern Utah, we can see the snow squall parameters, the higher values in kind of the purple and whatever other color that is, as opposed to blue, increasing as that line moves eastward. And then finally, as it moves east of the Wasatch Crest by 17Z, weakens considerably. So as that band is approaching the Wasatch Front, pretty strong frontogenesis. Alex mentioned the pressure couplets, a 2-hour surface pressure change. We saw values of about 4 to 5 millibars, increasing behind that boundary by 16Z, with 2 millibar pressure falls ahead of it. So a nice couplet of pressure falls and rises there. We were fortunate with the timing to get a pre-snow squall sounding with our synoptic sounding at Salt Lake. So the things that stood out here were fairly steep mid-level lapse rates, pretty good vertical wind shear, especially directional shear. If this was in the Central Plains, it had a little more instability. I'd be pretty excited about supercells, but so plenty of shear there. Surface-based CAPE was a little bit contaminated by a rather high surface dew point, but with the steep mid-level lapse rates and the increasing forcing with that wave approaching, we did have some marginal instability, which, as Alex mentioned, is one of the parameters that we look for. So here's the radar loop as that line moved across northern Utah through the Wasatch Front and then points east. I should mention that the high-res models, even the day before, were really nailing this event pretty well. So we had high confidence that we were going to see a band of intense snow move through the Wasatch Front during the pre-dawn hours and right into about sunrise or so. Confident enough that I actually got myself out of bed early and came into the office by 6 because I didn't want to be driving in it. So we can see that there as that line moves across the desert, really intensifies as it hits the eastern shores of the Great Salt Lake and interacts with the Wasatch Range, which is just east of Salt Lake City. So warning considerations. I mentioned that this was Sunday morning. It's in the pre-dawn hours. Not a lot of traffic. It's the day after Christmas, so not a lot of people out. A lot of people probably still in bed, hanging out at home. So with snow squall warnings, that activates the WIA notification system, and that is something we really did not want to do on an early Sunday morning, to tell people it was going to be snowing when it's kind of a minima in the traffic volume anyways. So we opted, despite the intensity of the snow band, to not issue a snow squall warning for this event, lighting up about 2 million phones along the Wasatch Front just seemed like a bad idea. So we issued a strongly worded SPS for snow squall, which was in effect for an hour, with winds greater than 45 miles an hour, visibility less than a quarter mile, and snowfall rates of 1 to 2 inches per hour. So as we get east of the Wasatch Crest, we start to run into some radar limitations. This is the 0-degree elevation cut from MTX, but there's quite a bit of beam blockage east of the Wasatch Crest. So it can kind of give the impression that that line is weakening as it moves east through northeastern Utah and into southwest Wyoming along I-80 there. Looking at some higher elevation scans, that can give us an indication that the line is still intact. The top left here is the 0.5 degree, 0.8 on the top right, 1.3 on the bottom left, and 1.3 on the bottom right, and then 1.8 on the bottom left here. We can see as we look vertically, that line is still intact, although sometimes in real time we're not always assessing that in terms of temporal continuity. We're not looking at like the 1.8 image consistently. So satellite imagery actually helped to identify that this feature was still maintaining its intensity as it moved east of the Wasatch Crest. Within that oval, you can see some of those yellows along the leading edge of that snow squall that remained intact as it moved across the Wasatch Crest. It did weaken a little bit as it approached southwest Wyoming, but you can certainly still see that band is maintaining itself. So that was a really useful tool, especially with the 5-minute GOES imagery. Unfortunately, we didn't think about grabbing a mesosector. We're still kind of in winter mode, and I have associated that with summer convection. So that was certainly a lesson learned on my part, was to think about requesting a mesosector if we have enough confidence that we're going to see an event like this. The true color imagery here. So one thing about the snow squalls in this part of the country, they're very shy, and they tend to develop around sunrise and sunset when we can't really use the full suite of RGB products to assess them. They don't really like to be photographed, but we were able, toward the latter half of this event, to catch after sunrise this line moving through southwest Wyoming. And I'm bringing this image up because you can still see those convective elements tracking east of the Wasatch Crest. So definitely another useful tool in showing that this line was in fact maintaining its intensity as it approached Evanston. So given that it was after sunrise, it's getting toward mid-morning, it's after 8 o'clock, we did go ahead and issue a snow squall warning for Uinta County, as given the idea that people were starting to move about, even though it was Sunday morning. Whiteout conditions, 0 visibility, and wind gusts greater than 45 were our main concerns there. And I-80 actually runs right through Evanston across southwest Wyoming, so that was our other primary concern there, was increased travel along the interstate as the morning progressed. So I know some of these numbers are a little bit hard to see, but we had widespread wind gusts of 40 to 50 miles an hour associated with this band. We actually had some gusts in excess of 60, like 62 up at Evanston. A couple of sensors out of the Great Salt Lake tend to perform really well. We had a 76 mile an hour gust up there. I think that's Hat Island or Fremont. I can't remember which one. with numerous reports of quarter mile or less visibility with a snow squall passage and rapid snow accumulation across the Wasatch Front at points east of 1 to 2 inches in a short period of time. So certainly very intense band. We also saw a fair amount of lightning with this system as well, even though it was during the early morning hours. So it was quite electrically active. It was actually our second thunder snow event in 2 weeks. I think we had a previous one on December 14th. It was more of a lake-induced event, but certainly quite an interesting event. So now we shift forward to the next day, December 27th. The long wave pattern didn't really change a whole lot. We still have the trough in the west. I guess that trough is starting to lift out of the Pacific Northwest. We have a shortwave trough where the latter half of this loop again moving across northeast Nevada into northwest Utah, with a fair amount of large-scale ascent associated with that trough as it lifts east. I'll take another look again at this event with the frontogenesis on the left and the snow squall parameter on the right. We see as of 19Z, this was more of a late afternoon and evening event. That's the frontogenesis up along the Utah-Idaho border, shows up nicely there in the left. Snow squall parameter not particularly strong in that area. As we step forward to 21Z, we see that FGen parameter intensify quite a bit along the Utah-Idaho border. And by 23Z, pushes south through northern Utah. The snow squall parameter up on the Utah-Idaho border certainly responds here with some magentas there, just north and east of the Gray Salt Lake. Some of that parameter, the snow squall parameter, is likely influenced or contaminated by the cold waters of the Gray Salt Lake and limiting instability within the model that's calculating that parameter. But as we step ahead to 1Z, we certainly see that FGen maintaining itself through northern Utah. And by 3Z, it starts to weaken as it pulls east. Again, a nice pressure rise or fall rise couplet across northern Utah, southwest Wyoming, not quite as strong as the previous event. We're still looking at rises about 3 to 4 millibars in 2 hours as a 1Z across northern Utah. Fortunate enough to get another pre-squall line sounding, representative of the pre-squall environment. Again, we see very steep lapse rates. I don't have the side-by-side here, but the low-level moisture below 700, the air mass was a little drier in this case, and I'll show in a minute why that kind of contributed, if we think, to a lack of lightning in this event, but certainly still steep level lapse rates and fairly strong deep layer shear. So the radar image of this event crossing the northern Utah, the Wasatch Front, as that line approaches, we again see it intensify as it hits the lake. However, we start to see around the middle of the loop that part of the outflow of that line really starts to surge south and east. That tends to happen a lot across the lake, which is with a lack of friction. If the cold pool associated, I mean, snow squalls basically act the same as any kind of convective line. And if the cold pool overwhelms the deep layer shear, and there's really no friction out over the lake, you'll tend to get the outflow race out ahead of the parent updrafts and weaken the line just a bit. So we did observe that here. I think that likely contributed to why we didn't see any lightning. The other thing I'll mention with this event is the December 26th event, the high-res models handled that really well. This event, not so much. A lot of the models were kind of killing this boundary as it moved east across the deserts west of Salt Lake City, or dove it south along the Utah and Nevada border. There was not a lot of guidance suggesting that this line would hold together all the way into the Wasatch Front. So our confidence was certainly not as high going into this event. But looking at satellite imagery, this is again the IR loop for late in the afternoon. We do see cooling cloud tops within that oval, and that's across northwest Utah, moving across the Gray Salt Lake. So as we were looking at satellite imagery and seeing that this band was holding together really nicely, and in fact we're getting cooling cloud tops and it was likely intensifying, that gave us high confidence that ignoring what the models were saying, this thing is definitely going to hold together and get into the Wasatch Front. So we started thinking about snow squall warnings, whether we need those at that point. We were able to catch a glimpse of this just before sunset. Again, these things don't like to be photographed apparently in satellite imagery, which limited our use of the RGBs to fairly narrow windows. But we are able to see with the sandwich product that some of the convective elements, I really like this product because you get the cooling cloud tops, you can get an idea what's going on with cloud top temperature, but also retain the resolution of the visible imagery. So you can really pick out the convective elements and see that there's still quite a bit going on there along the leading edge of that line that moves across the Great Salt Lake. So certainly at this point, our confidence was high that this was going to hold together and get into the Wasatch Front. So warning factors with this event, now we're looking at afternoon and evening. Although it is post-Christmas, there's still an afternoon evening commute. We have an obvious snow squall moving into the urban corridor. We felt really good about activating WIA in this case to try to give people a heads up, given the higher traffic volume, that try to get off the roads or do whatever you need to do. So we try to get as much lead time with this as we could. At least that was our goal. So we issued the first ever snow squall warning for the Wasatch Front at 4 o'clock. We only put it up for a half an hour for points from Ogden northward, kind of the far end of the northern or the Wasatch Front, looking for extremely low visibility of blowing snow and gusts of 40. That was only up for a half an hour. In hindsight, I wish I would have issued that longer. So we had to reissue that at 4:30. This one was for 45 minutes. So the reason I say I wish that we would have issued it longer is because with WIA, I don't feel very good about activating people's phones multiple times. I think one notification is probably plenty. So that was one of the takeaways. And we'll discuss this at the end about how to handle some of these events. But anyways, so the line was moving into the Wasatch Front at this point. It was already through Brigham City, still approaching Ogden. So we felt pretty good about that. Again, extremely low visibility, wind gusts greater than 30, so that certainly met the criteria. Southern end of that line, crossing I-80 west of Salt Lake City, impacting travel there. So we also issued a warning there. We're trying to issue these warnings taking into account meteorology and political boundaries and the fact that we'd be activating people's phones and trying to weigh those three things and how we were doing this. So we were trying to not overlap boundaries too much, basically. So we didn't go into Salt Lake County yet. We weren't totally sure the line was going to hold together into Salt Lake County. So that's why we drew this line a little bit further west. And finally, as that line approached the metro area, or the valley, the Salt Lake Valley itself, we finally felt good enough that, yeah, I think this is going to hold together. It's got quite a bit of wind with it. So we did finally issue the snow squall warning for Salt Lake Valley at 4:51. And then we continued east. In the interest of time, I'll just step through a couple of these. We ended up warning again for Evanston. And finally, as the snow squall was kind of transitioning into more of a frontal band, it had become more oriented parallel to the mean upper flow. It was just kind of gradually moving southeast. We kind of debated whether to extend this down into southern Wasatch Front, Utah County, where Provo is located. But the northern part of that valley can get pretty nasty with frontal passages, a lot of downslope wind, and we've had some blizzard conditions there in the past, so we did go ahead and extend that there. We again saw widespread wind gusts of 40 to 50 miles an hour, numerous reports of quarter mile or less visibility with the squall line, and rapid snow accumulation of 1 to 2 inches again with this line, a little higher in southern Salt Lake and in the Utah counties where that line kind of slowed down and maintained itself for a while. So with that, I'll turn it back to Alex to look at a little bit of traffic data.
All right, thanks, Mike. As you can see here, one of the most important discriminators between high impact events and the lower impact events is the presence of a flash freeze on the roadways. And this is a study that looked at the distribution of road surface temperatures and air temperatures, both before and during snow squalls, during 11 pileup cases. And one thing that stands out here is the wide distribution of road surface temperatures pre-squall. And in some of these cases, road surface temperatures were 45 degrees or greater ahead of the squall. So, and I know I've been guilty of this in the past, looking at pavement temperatures, thinking we should be fine. Pavement temperatures are pretty mild, but these heavy snowfall rates can quickly overwhelm those milder pavement temperatures. And that's what we saw in every one of these 11 cases where a pileup was observed. During the squall, the road surface temperatures fell below freezing in every one of these cases. Oftentimes, this occurs in 15 minutes or less. And also, this was accompanied by, in 97% of the cases, air temperatures that were sub-freezing. So we're fortunate here to have a great relationship with the Utah Department of Transportation, and they were able to share some traffic data with us. So we wanted to look at how these snow squalls impacted society by way of traffic speeds. So what you see here is a calendar view of traffic speeds through the month of December. We'll focus in on the 26th and 27th. You notice during the 26th, as Mike mentioned, that was a Sunday morning, so the impacts to traffic were very limited. But on the 27th, this snow squall passed through the Wasatch Front during the peak of the evening commute. And what we can see here is that traffic was in fact impacted. And we'll, on the next slide, zoom in on the 27th a little bit closer. So on the x-axis here, this displays time throughout the day, and on the y-axis, that's the distance. It looks like it's about 20 miles from north to south. So we're examining the I-15 corridor from north to south across the Wasatch Front. And what we can see here is that traffic speeds rapidly decreased from 75 miles per hour or greater in the green shading to, in many cases, 25 miles per hour or less in the span of under an hour. And you can actually see the progression based on the traffic speed data from north to south there as the line moved from north to south across the Wasatch Front. So we took a look at some traffic data at site locations at roadway information sensors. And what we graphed here is visibility and traffic flow. So on the left side image here, we can see when the snow squall was issued, there was a slight increase in traffic volume. And then another thing to note here is how quickly the traffic volume dropped off once the visibility started to decrease. And in this case, the visibility decreased from 10 miles to a quarter mile or less at both locations. On the right side image, we can see the same thing, a slight increase in traffic volume after the issuance of the snow squall warning, and then a rapid decrease in traffic volume coincident with the decrease in visibility. Looking at another site, we can see another increase in traffic volume along and after the issuance of the snow squall warning, and another rapid reduction in visibility from 10 miles down to near zero in less than 15 minutes with the arrival of the snow squall. So we need to do some more examining here, but anecdotally, we think that there could have been an increase in traffic volume with people rushing out to do some last minute errands or trying to get home quickly before the arrival of the snow squall. So some societal factors worth examining. Here's a look now at road grip and traffic speed trends at I-80 and I-215 interchange. So first of all, what is road grip? Well, it's a measure of the coefficient of kinetic friction between the tires and the road surface. And grip levels or coefficients of frictions of 0.82 is the theoretical maximum that's achieved during dry pavement. And during snow and ice conditions, the coefficient of friction is usually 0.4 or less. During icy, very slick conditions, less than 0.2. So this particular site was on the Sunday morning of the 26th, and we can see a pretty steep reduction in traffic speeds and also road grip with the arrival of the snow squall from dry pavement down to icy pavement in the matter of about a half an hour or less. But if we go ahead to the next day and examine traffic data here, we can see a very sharp reduction in grip levels and a very sharp reduction in the coincidence traffic speed. So what we're seeing in both cases is a flash freeze, and that's especially evident here on the 27th case with a very rapid reduction in road grip, which is of course very hazardous for drivers because it indicates very rapidly changing conditions over a short time span. And just some screenshots I took of my phone of the Google traffic conditions. This is a tool that can be used to help assess impacts that are occurring on the roadways as it updates very rapidly. And you can see how conditions deteriorated on the 27th, on the evening of the 27th, as the snow squall progressed south through the metro area. So this is over a span of about a half an hour where traffic decreased from normal speeds down to, in some cases, as I mentioned, less than 25 miles per hour. And then I'll pass it back over to Mike for some items to ponder.
Yeah, just to wrap it up, these are some items that kind of came up internally, so I just thought I'd share them as things to think about. Alex mentioned that when we issued the snow squall warnings, that actually there was a notable increase in traffic, likely people trying to get wherever they were trying to go or where they needed to go, possibly leaving work or whatnot. So obviously we want to focus on lead time. What's the appropriate amount of lead time ahead of the line? We also ran into an issue, at least in my mind, where we had snow squalls expiring, but we still had fairly heavy snow well behind the line. It's a little bit different than a convective line, like when you think about your typical squall line in convective environments where you get that leading edge of the line, the strong winds and everything, and then you just have the stratiform rain that is not that impactful. But in this case, that's where a lot of your moderate to heavy snow persists. So certainly letting warnings expire and then the conditions are still really terrible out there was something that we ran into, especially the second event. Again, I mentioned this, but avoiding activating WIA multiple times. And then since we never issued a snow squall warning here, there was a lot of questions on social media about what is a snow squall. I've never heard of that before. So kind of trying to emphasize preseason awareness and education campaigns, before the season starts, social media posts, web pages, that kind of thing. So just some items to kind of think about. We were internally going to ponder how to, handle these going forward. So with that, that is what we have for presentation. If anybody has any questions, we'd be happy to answer.
Thank you very much. And I'm going to start off with one because the Great Lakes and East just had a fairly long track snow squall with snow squall warnings from Duluth all the way into Pennsylvania and Albany East. So I'm kind of wondering if the snow squalls in your forecast area are that long-lived. I mean, I saw a couple of them when they were moving into Wyoming. Do you then coordinate with, I guess it would be Riverton, to say we have a snow squall warning, or how does that kind of inter-office communication happen? Or do they just not last that long out west? I don't know.
It definitely happens, and we try to notify, like in the case of both the 26th and 27th, we'll either post in chat or give, like in that case, Riverton a call. I think we just posted in chat that, hey, we issued the snow squall warning for you in a county. It's in effect till, whatever time, and just make sure that they're aware of it, of what we're doing and watching it. So that interaction definitely happens. It varies between whether it's via chat or we may pick up the phone if it's kind of a short notice thing to make sure that they're aware of what we're doing so they can kind of monitor and track what goes on their side. The interesting thing out west is that a lot of our CWA boundaries are largely unpopulated. So, with I-80 going east out of Salt Lake through southwest Wyoming, they certainly impact their I-80 west into Nevada with Elko. But there's a long swaths of border that just are simply unpopulated. So we try to focus on those impactful areas especially. But anytime we're issuing headline like warnings, advisories, we try to at least chat with the neighboring office so that they're aware. And we also want to know what they're thinking as well.
And to answer the longevity question, in the case of the 27th event, this line actually formed near Reno and propagated east throughout Nevada before entering our forecast area. Not sure what the longevity looked like in the 26th event, but the 27th event did impact at least 3 states.
Wow. Okay, thanks. I noticed Mike Wessler had his hand up, and I was trying to figure out how to unmute him so he could ask a question. So Dan, if you could unmute him, and maybe he can ask a question. And Doug Wesley also has his hand up.
Wesley was an accident. He didn't mean to raise his hand.
Oh, Wesley's in the other room. He said it was an accident. Didn't mean to raise his hand.
Hey, can you guys hear me?
We can hear you. Yep.
Yeah, thanks for the great presentation. I'm particularly intrigued with your use of the UDOT data, and I shudder to think of what would happen if you're on a highway out there and the visibility suddenly goes to 0. It would be a pileup situation, it'd be scary. But my question is, do you think people are trying to anticipate the onset visually along with their telephone warnings and whatever, in terms of these last minute surges in speeds and volume, do you think they're trying to interpret visually what they're seeing, and maybe they can get something done prior to it hitting?
Yeah, that's a good question. We did go back and look at some comments that were posted on local media pages, and people mentioned, trying to get some last-minute errands accomplished before the arrival of the squall, like picking up some grocery items, for example, or just trying to get home from whatever location they are at, so they could be home safely. But in terms of what they might anticipate in terms of visibility or road conditions, don't have the answer to that question, but that's certainly something we'd like to find out. That's a good question.
Yeah, I think it could get people in trouble quickly. So
yeah,
definitely, that was kind of an interesting result in the traffic data. I can say one of the staff members at the Colorado Basin River Forecast Center on the 27th event actually came over and asked us if she had enough time to get home before the line hit. So we told her, if you leave right now, yes. But I think there is certainly an element of people get the notification on their phone, they look outside and visually they can, it's not snowing yet, so I got a little time. But that can, like you said, get them in a lot of trouble. So I think that, again, going back to lead time, that's something that we probably need to think about.
right, yeah, and these things aren't always linear as you look at them either. We all know that. So I have just a quick question about the two photos you have of snow squalls from Salt Lake. Are those these two events, or are those just past events, just historical cases?
Those are from the afternoon of the 27th. Local, some member of the public was posting them that he was shooting as the line moved into or approached the valley to the Wasatch Front. So those are actually from the December 27th event.
Okay, thanks.
It was a little bit too early. It's still largely dark when that line is approaching the Wasatch Front.
Okay, I'm mindful of time, so I'm going to ask you one more question that came in from Brian Mata. So it's about nighttime detection of these. I'm assuming the webcams are giving you useful information still at night, and you showed some infrared, clean window infrared data, but are there other products you could use at night to help gauge the intensity of these?
That's a good question. I know I like to rely on the microphysics RGB quite a bit, but there was so much cirrus blow off in this case that it wasn't terribly useful during the early morning hours. That's why I kind of reverted back to the clean IR imagery. Yeah, nighttime is a little bit challenging because you don't have the sandwich product I mentioned. I really like because you can see the high resolution visible imagery overlaid or with IR overlaid on it. You can't really do that at night, so you're just kind of left with some lower resolution imagery. And if you're getting a lot of cirrus covering up some of that other activity, it can be challenging, I think, to find the appropriate satellite channel. Sometimes you might get lucky and you don't have all that cirrus, but in this case, it wasn't. It was kind of challenging.
Okay, thanks. Yeah, I don't think we have time for further questions, but I'd really like to thank our speakers, Mike and Alex, for a really interesting presentation on snow squalls in Salt Lake that I personally lived through. So one of the first times my phone ever went off for a snow squall warning while I was in Utah. Thank you for your presentation, and everybody have a great day.